Part of this chapter is involving conics, and we'll talk more about what is a conic, what makes a conic section, and so on. But we want to supplement a little bit with circles to make sure that everybody's on the same page and that the skills that we learn today will help us with the other conics that we're working with tomorrow and the rest in next week. So first of all, here's a picture of a graphed circle. What's the center of this circle? 0, 0. Okay, so we're on your handout, very top blank. The circle centered at 0, 0. And every point on that circle is the same distance away from that center. How far is that distance? 5. How do you know? Yeah, because 0 to this guy, we can count horizontally, but not diagonally, right? So 5 this way, 5 this way, 5 this way, 5 this way. Draw your circle around there. Your radius is 5. So, based on what you observed earlier, what's the equation of this circle going to be? Kristen? I like it. X squared plus y squared equals 25. And he was heading down the path to say, hey, if we want to use zeros, we could say x minus 0 squared plus y minus 0 squared equals 25. But those zeros aren't necessary, so a lot of times we don't bother. Does that make sense to everyone? Okay. So a circle centered at 0, 0 with a radius of 5 utilizes the Pythagorean theorem, right? Any point, any xy on this circle, doesn't matter where, can cross the grid or not, is going to have to fulfill an equation that says x squared plus y squared equals 25. You can plug any of those coordinates in, and we'll get a true equation. So far, so good? All right, let's keep moving. So here's another circle with a radius of 5. But this time, it has a different center. What's its center? That one's 1, 2, and I don't have the same one as on your paper, right? So on your paper, what is its center? 3, 2. So let me go to the next one. Okay. So you have a circle with a center of 3, 2. And we said its radius was 4 in this case. So when we're looking for the equation of a circle with a center of something other than 0, 0, we use the form x minus h quantity squared plus y minus k quantity squared equals r squared, where h comma k is the center of your circle and r is the radius of your circle. Okay. So what will the equation of this circle be? Very good. Why did we have to do a minus 3, I'm sorry, a plus 3, I'm sorry, minus 3 and a minus 2? Yeah, the points were positive. So in order to make it work, we have to basically shift it down to the origin, don't we? And how far away are we from the origin? We'd have to go 3 to the left, right? And 2 down. And then we're back to where the center would be at 0, 0. And then it works well with the Pythagorean theorem. Okay, so questions on this one? All right, there's a spot for your equation to be going sideways. And then, I did it side, I kind of trying to save space. Where's Waldo type of thing? Where do I put this equation? Okay, so then, here's another applet from GeoGebra. Kind of like the way this gentleman designed it, because you can grab the sliders to move it anywhere you want to go. So his red line, or the red slider, is going to impact the r, right? How big is the radius? So we can slide the radius, make it larger, or we can make it smaller. And then it just kind of helps you see that if I move to the right, then my x is going to go x minus 3 in the parentheses. And if I change my horizontal movement left, then basically to get back to 0, I'd have to go right 8, wouldn't I? So x plus 8, comma 0. And if I go up and down, I move up 3, it's y minus 3. And I move down 5, it's y plus 5. Okay? So now I have a circle with a center at 2, -1, and a radius of 6. And I want you to write the equation of it in standard form. All right, Jax, what's your equation going to look like? X minus 2 squared. Very good. It's like squared, which is, yeah, we'll just call it 36 right away. Very good. Okay. So x minus 2, to get it to the center, we have to go 2 to the left. To get the center to the 0, 0, to the origin. The y plus 1, because if we wanted to move that to the origin, we would have to move it up 1. Squared equals 36. Okay, questions on this one? All right, so here it comes a little more difficult. Because now we've got a center, and we have a point that's on the circle. And we're trying to figure out what's the equation of the circle. So what are we missing? The radius. How could we find the radius? Pythagorean theorem if we graphed it. Absolutely. So you're taking a y sub 2 minus y sub 1 over x sub 2 minus x sub 1, but that's more of a slope, right? But you're on the right track. Over 2, when you're adding and putting them over 2, you're finding a midpoint. So you're on the right track. You guys are you're in the right ballpark. What are we looking for? We want to know the length of r. We want the distance. What's the distance formula? So in this case, it would be r. Square root of yep, you're thinking in the quadratic. So x2 minus x1, I tried to write a y. Good. Perfect. Okay. Now, did you notice on the ACT that they didn't give you any formulas? You had to know the formula for midpoint. On the practice test that we took, you had to know the perimeter of a rectangle. You had to know the area of a rectangle, right? You had to know the circumference of a circle. So when we gave you NISA sheets and said don't bother to memorize things, I think that was harmful. You need to know your formulas, especially the basic ones. Okay? So that's a distance formula, but let me show you another way. Let's write this out as, if this is the center, what's it going to start out as? And we don't know r, right? Okay. So I know a point that would satisfy this equation, don't I? -6 or 6, -12, right? Can we put the 6 in for the x and the negative 12 in for the y? And then find out what r is? That makes sense? So watch what happens. 6 minus 3 is 9. 3 squared is 9. Negative 12 plus 4. So negative 8 plus squared is 64. So what's 9 plus 64? It's 73. So we're going to have 73 as r squared. So square root of 73 would be r. So now we rewrite our equation as x minus 3 squared plus y plus 4 squared equals square root of 73 squared. Didn't we just use the distance formula? We took our 6 x2 minus x1 minus 3 squared plus the y2 negative 12 minus a negative 4 squared. So the equation of a circle is basically the distance formula in disguise. Does that make sense? Okay. Questions on this one? All right. So here's where it becomes a little more difficult because this is something we haven't seen in geometry class. We didn't ask you to solve these kinds of problems. They would be in standard form asking you what's the center and radius, or they'd give you a center and radius and ask you what the standard form is, back and forth. Okay? But now we have basically taken that equation and we've FOILed it all out, right? And then brought all the numbers to one side. So how are we going to go backwards? How are we going to make this into an x minus something squared plus a y minus something squared equals r squared? Absolutely. We want to get it into an x minus something squared plus a y minus something squared equals r squared. So we need a perfect square trinomial here. And we also need a perfect square trinomial there. So we're going to have to add some numbers to make that happen. Make sense? What is that called? We did it first semester, first quarter. Completing the square. Yep, we just need to complete the square. But we have to do it twice now instead of once like we did with parabolas when we were trying to find the vertex. Okay? So the key to doing this is, first of all, we're going to gather ye rosebuds while ye may. We're going to get our x's together. Leave some space. We're going to get our y's together. Leave some space. And then we're going to put our negative 11 over here. But it will be still, yeah, negative 11 over on the right side all by itself. Okay? Then we have to ask ourselves, what would we need to add to x squared minus 8x to make a perfect square trinomial? 16. And the way to remember that is that we have to take half the middle term squared. Remember this? Coming back to you. Okay? So we added 16. Now, what are we going to add to the y portion of it? Because half of 4 is 2, 2 squared is 4. Now, anyone who has twins in their family or even two siblings that are very close in age, if you give one of them a lollipop and you don't give the other one a lollipop, what happens? They fight. They get mad. They cry. They have a tantrum, right? Especially when they're young. That happened with you guys, David? No? Okay. So I'll give Jonathan something and you'll be fine with it? He's more mature now. So if we add 16 and 4 to the left side of the equation, what do we have to do? Do it to the right. So we need to add 16 and 4 to the right side of the equation to balance it, to please the algebra gods, right? And so we'll have 9 on the right-hand side. Yes. The algebra police, right? Gotta keep up those laws of algebra. Okay, so what is our perfect square trinomial on the left side? Squared, right? What's our perfect square trinomial here? Because this would factor into x minus 4 times itself, and this would factor into y plus 2 times y plus 2, which is what we were doing, right? That's why we picked half of the middle term squared. We did this by design. Okay? So now that we see that, what's the center? 4, negative 2. And what's the radius? R equals 3. Oh, that's not horrible. Because we've done it before. We just have to dust off the cobwebs and remember how to do it again. All right, one more example. Same thing. Get your x's to one part, move your y's together, and get your constant onto the other side of the equation. And ask yourself, what's half your middle term for your x? And then square it, add it in to both sides of the equation. And find your half of your middle term for y. Square it and add it to both sides of the equation. And we won't square negative 22, but chances are we will have enough good stuff coming from the other side to make it positive. So we can't have a negative radius, right? All right, so did you get x plus 5 squared plus y plus 1 squared is equal to 4? So what's your center? And what's your radius? Okay. So you can do this, right? All right. If you flip your notes over, that's your assignment. Yes, sir. Give me 1 second. The 1 came from, good question. So, yep, half of 2 is 1, and then 1 squared is 1. So then we have to make sure we add it to both. Any other questions on this one? All right.